Picture this. You finally launch your AI resume analysis. A user uploads a 10-page CV. Your front end calls your backend, which calls your GPT-4. You wait 10 seconds, 20 seconds. Suddenly, 504 gateway time. The user sees an error and leaves. But here's the kicker. Your OpenAI call might have actually finished 5 seconds later. You just paid for an analysis the user will never see. This is the synchronous trap. If your user has to stay on page for a minute while a model processes, you haven't built a product. You have built a demo. Today we are moving into big leagues. We are building a reliable AI job queue using nothing but PostgreSQL. No Redis, no RabbitMQ, just pure atomic SQL logic that scales. To solve this, we need to decouple user interaction from AI processing. Think of it like a restaurant. The waiter, your front end, does not stand in kitchen waiting for your steak to cook. They take your order, put a ticket on the board, and go help the next customer. In our system, the ticket is a row in our analysis table with a status of queued. The front end receives a 202 accepted response instantly. The chef is our background worker. It's a separate process that sits there watching the database, waiting for a new queued ticket to appear. This architecture ensures that even if OpenAI takes 2 minutes, your user's browser never times out. Let's look at the database schema that makes this possible. We have two key tables, resumes and analysis. The analysis table is our state machine. We don't just use generic status string. We use a check constraint to enforce four strict states: queued, processing, completed, and failed. Why does this matter? Because in production, zombie jobs are real. If a worker crashes, you need to know exactly where the job stopped. We also track input tokens, output tokens, and duration. If you aren't tracking AI costs at database level, you are flying blind. We treat AI tokens like server RAM. It's an infrastructure metric you must know. Now, here is where most junior tutorials fail. What happens when you have two workers? If both workers ask the database for the oldest queue job at the same time, they might both pick same job. Now you're paying for two GPT calls for same resume. The solution is for update skip logged. This is a senior level PostgreSQL feature. When a worker A selects a job, it logs the row. When worker B runs the same query, it sees the log and literally skips to the next available job. It's atomic, it's thread safe, and it allows you to scale to 1,000 or even 10,000 workers without a single collision. This is the difference between a side project and a 20 LPA portfolio piece. But what if a worker claims a job and then server goes down? The job stays in processing forever. We solve this with timeout reclamation. Our reclaiming function looks for the job that have been processing for more than 5 minutes and automatically puts back them in the queue. It's a self-healing system. And for the user experience, we use Supabase Realtime. The frontend subscribes to the changes in our analysis table. The moment our worker updates the status from processing to completed, the frontend gets a notification and instantly renders the results. No refreshing, no manual polling. It just works. By using Postgres as our queue, we keep our stack simple but our logic professional. We have got deduplication to save money, atomic locking for scale, and real-time updates for the wow factor. Next week, we are finally going to write the background worker code, the Node.js logic that actually talks to OpenAI and handles those PDF files. If you want the SQL code for claim next job analysis function. Check out the GitHub link in the description. Don't build fragile apps, build systems. I will see you in the next one. Till then, bye and take care.